Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, welcome to our 10th lecture. Today, we are going to learn how to size a diffuser, and I'll give you an example, and we will see briefly how to TAB means testing, adjusting, and balancing a diffuser. Okay, first of all, please remember and recall back what is throw in the previous lecture. We have seen the meaning and the illustration of throw in the previous lecture. To size an air diffuser, we need to consider several factors or criteria, which are ventilation rate, throw, pressure loss, and noise level. What is pressure loss? Pressure loss is the pressure resistance to airflow and is required in duct and fan sizing calculations. And noise level, the maximum noise level is different for different room types. So we have to see a table, and the table will be shown in the next slide. Basically, you have seen this figure. Just to recap, a throw is the distance from the air supply, that is being thrown out of the air conditioner, and the distance of the thrown air is the throw. And at the end of the throw, where the velocity does not change anymore, we call it terminal velocity. And the envelope of the airstream is shown on the dotted lines here. This is the envelope of the airstream. Alright. So this is the noise control table, or will be used in short form, noise control, as NC. So for different types of space, for example, for broadcast studios, we have 10 decibel of noise level limit. And for different types of buildings, it will be different. For example, in hospital and clinics, we have private rooms, wards, operating rooms, lab, corridors, and public areas in a hospital. And for different types of rooms in the hospital, there is different noise control range for it. The unit is in decibel. Alright, so what is ventilation rate? We always hear about ventilation rate, and the unit in SI unit, it is in meter cubic per hour. Ventilation rate is actually equals to the air change rate per hour times the room volume in meter cubic. And the air change rate is also abbreviated as ACH, or AC over H. H is hour. AC is the air change. Air change rate is a measure of air volume added or removed from a space, and it is divided by the volume of the space. That is why the unit at the beginning is meter cubic over meter cubic, so it cancels out. Therefore, the air change rate only has unit per hour. And the suitable air change rate for different types of space is also different. For example, for business office, we have 6 to 8 air change rate per hour. And for public buildings, for example, for restrooms, let's say, we have 10 to 12 air change rate. So we really have to refer to the table before we decide what is a suitable air change rate for a space. Now, let's look at this example. Design the diffuser system for the supply and return air ventilation for the room shown below. And this room, we have to see the type of room. This is an audience studio. So according to the table, the air change rate for this audience studio is 10 air change rate per hour, and the noise rating level for the audience studio is 25 decibel. It cannot exceed this 25 decibel. And the throw required is a ceiling height minus 0.8. So the ceiling height we have here is 3 meter. So minus 0.8, then we have throw is equals to 2.2 meters. And the pressure drop, we have to keep the pressure drop below 20 Pascal. And in this question, it is said that we have to keep the pressure drop below 20 Pascal. And use Waterloo SL-M series 4-way diffusers. So you really have to see how many way of diffusers should be used in your design. Sometimes it is recommended by you as a HVAC engineer or designer, or it is already required by the client, so you have to ask the client. Okay, so the size of the room is 10 meters times 6 meters and times 3 meters the height. Width times length times the height. Okay, to choose a diffuser, you have to first calculate the ventilation rate. If you see in this question, it is given that it should have 10 air change per hour, and the size of the room is also given. So you just have to recalculate it into liter per second. So if you see here, the size of the room is actually 180 meter cubic times 10 air change rate per hour. Then you will have 1800 meter cubic per hour. And you just convert this ventilation rate into meter cubic per second, so that you can convert it later into liter per second. So you know that 1 hour we have 3600 seconds. So to convert a meter cubic per hour to meter cubic per second, then you will have to divide this number with 3600. Then you will have 0.5 meter cubic per second. And later, just time this figure with 1000 to get 500 liter per second. Okay, now you know that the ventilation rate in liter per second is 500. Okay, this is normally a table from manufacturer to choose a diffuser. And in this question, it is already given that you should choose from a certain model. And this is the model from the related manufacturer. And this page is already for 4-way diffuser. And the airflow rate is already given in liter per second. So from this table, you will first have to know the diffuser layout. Why? Because if you know what is the how many diffusers are used in the layout, then you can divide this amount of airflow rate in liter per second into the number of diffusers used. For example, if you use 4 diffusers, then you will have to divide the 500 liter per second into 4. Okay, let's see the next slide first. Alright, this is the calculation. The table just now is the Waterloo catalog, and the design criteria is already given, which is we should have throw 2.2 meter, noise control level 25, and the pressure drop should not exceed 20 Pascal. So if we have 2 diffusers, then you will have to divide the 500 liter per second into 2. So per diffuser you will have 250 liter per second. But if you choose 3 diffusers in your layout, so you will have to divide the 500 with 3. Then you will have 167 liter per second per diffuser. And if you have 4 diffusers, now you will have to divide the 500 liter per second into 4, and you will have 125 liter per second. And for each types of diffuser, you can see the suitable model by looking at its throw, its noise control level, and also the pressure drop. Whatever you choose, you have to abide that you follow the requirement that is already given. The design criteria should have throw about 2.2 meter. Noise control level should not exceed 25 decibel. And the pressure drop should not exceed 20 Pascal. And from this all 3, if we choose 4 diffusers, we will have 1.5 meter throw, and the noise reduction level, the noise reduction is negative, and the pressure drop is 9 Pascal. So it still not exceed 20 Pascal. So the 2 diffusers is out because the pressure drop exceeds the design criteria. 33 Pascal is way too high compared to 20 Pascal. And if we choose 3 diffusers, then we will have 2 meter through, 23 noise control level, and 15 Pascal pressure drop. This one is checked, this one is checked, but this one is not. So if we choose 4 diffusers, then we'll have 125 liters per second per diffuser, 1.5 meter through, and there's no noise reduction level required. And we will have the pressure drop about 9 Pascal, which is way far better than 20 Pascal, the design criteria. So if we choose this one, because the noise reduction level is checked, and also the pressure drop is also checked. So if we choose this one, then we only have to deliver 125 liters per second per diffuser. So from the table, then you can refer later. The chosen one is the diffuser with the number M450 over M500 with throw 1.5 meter and pressure drop level. Pressure drop is 9 Pascal. Okay. You have to remember, if you choose the pressure drop, the lower pressure drop, then your operating cost will also be lower. All right. So this is the diffuser layout. Based on how many diffusers you choose, then you will have your diffuser layout. And this diffuser layout should consider the ceiling layout and also the lighting layout. We do not want to have a diffuser coincides with a light. So you really have to know where is the light, and to avoid the space for lights to be taken by diffuser. And the arrangement of the diffuser is also very important, because you would want to distribute the air evenly, and you do not want that a space, for example here in the corner, at the corner, suddenly you didn't have any airflow. So the person who sits under this area, under this diffuser, will suffer. So you really have to look at everything, including the ceiling layout, the lighting layout, the table arrangement, and so on. Right, let's take a look at an example. If you have block 1, so we'll see only one example, even though we have 2 here, but you can repeat the same process for both buildings. If you look at the block 1 factory with heavy activity, and this is the size of the building, the factory, which is 180 feet times 60 feet, and the refrigeration ton is 128, and the required CFM is 40,370 CFM, and the ceiling height is 10 feet. Okay, how to choose a diffuser for AHU1. First, you have to refer to table for factory application and office building application to get the permissible noise control level. How many decibel? So please look at the previous table, because I cannot go to the previous slide. So please scroll the video at the bottom and see the table of noise control level. So what is the figure that is permissible for factory application? Okay, if you see the table, you will get the NC level is between 35 to 50 decibel. And based from the CFM, or the air flow rate in cubic feet per meter, cubic feet per minute, divide with the numbers of diffuser that we want to allocate, then we will get the airflow rate per diffuser. So just now we have 40,370 CFM. Let's say we want to use 60 diffusers for the space, for the factory space. Then we will have about 673 cubic feet per minute for a diffuser. And please remember, do not exceed 50 decibel, the noise level, the noise control level. So if you see the catalog, in this example, a diffuser is chosen which has a size of 15 inch times 15 inch, and the airflow rate is 698 CFM. It's a bit higher than 673 CFM. It's okay, because in air distribution system, there's no way that you can get exactly the number that you want, because the control of air can never be too precise. And for this size and this amount of CFM, you will have neck velocity of 500 feet per minute. And if you see the catalog, then you can see what is the throw for the diffuser. And in this case, we have 19, 27 or 37 feet throw. And the noise control level is 28 decibel. And if you see here, it's still in this range, or does not exceed the range of 50 decibel. And this is a model number for the related diffuser. So basically, this is the AHU box, which has 40,370 CFM, and this is the diffusers, the arrangement of diffusers. So basically, this is a diffuser's layout, so that you can see how it can be arranged before the real installation. Okay, so basically you can repeat the same steps for the other block, which is in office general perimeter. Why is it so important to have this ducting layout? Yes, exactly. To have the arrangement of the diffusers, and also to see what is the location of a suitable location for main duct or rigid duct, so that you can plan where is the main duct and where is the branch duct, so that all diffusers will get the even distribution of air. Alright, so you can see here a diffuser will cater only 673 liter per CFM, and the bigger trunk here is the main duct. And also here we have two main ducts, and per duct we will have about 20,200 for the main duct, because we have at the beginning in the AHU, from the AHU it's 40,400 approximately, and we divide into two, then per main duct we will have 20,200, and from here we will reduce further, and it is to remember that a diffuser will have 673 CFM. Okay, as the duct go farther away from the AHU, then you can see here the CFM is reduced. Okay. After you get the CFM and you get the suitable velocity, it depends on what method you choose, the velocity reduction method or static friction or regain, so whichever, then you will get your CFM and your velocity, and also your static pressure loss, and from here you can plan what is the size for your main duct and also for the branch duct. If you see here, from AHU we have the biggest duct size, and as it goes away from the AHU, then the diameter of the duct becomes smaller and smaller until the end it only has about 12 inch diameter. Okay, this process is about the same. Here it's only shown the coordinates, so how to arrange your diffusers according to these coordinates, so that when comes the man for installation, then they can refer to your drawing and see where the diffusers should be. Alright, so we come to our end of lecture or sharing. The air balancing is a very essential step to adjust the damper so that the flow rate of each diffuser is equal. And other method is to determine the cooling or heating load of the room to come out with the ventilation rate that we desire or we already designed. Okay, so we have air balancing, which involves testing, adjusting, and also balancing, or the short form is TAB, testing, adjusting, and balancing. The more complex is your system, then the more is the air balancing is needed. And this process includes number of related tests. It involves several tests to determine the performance of your air conditioner and also the heating process if it involves heating. And the purpose of this testing, adjusting, and balancing is to assure that your HVAC system provides the maximum occupant comfort at the lowest energy cost. We do not want to incur costs, unnecessary energy costs. So this test will involve several equipments, includes manometers to measure the pressure, hygrometer to measure the humidity, thermocouples to measure the temperature, and also the dial thermometer to measure the fluid temperature. And all the results of all these tests are compiled into a report, and the analyzer, the HVAC engineer, will determine how well your system is functioning. And based on this, they will decide what to do to give some balancing or etc. Alright, this is one of the tests. Basically, this is a flow measuring hood here, and the procedures of this testing, adjusting, and balancing, it will be talked further in your lab session. So I think this is that's all from me for this lecture, and see you in the next lecture. Thank you.